Hello and welcome to this video explaining the trends in reactivity of group 1 and group 7 elements in terms of their readiness to lose or gain an electron. During this video I will be going through this learning objective and going through 2 exam questions associated with this also. So there's the learning objective. So the trends in reactivity of group 1 elements. So the group 1 elements are called the alkali metals. And the trend in reactivity is that it increases as you go down the group. But why? Group and 1 elements all share the same characteristic. They all have one outer electron. This means, however, they are very unhappy or very unstable, and they all want to lose that electron to form a noble gas configuration. So the reactivity, when they react, they would lose that electron. So the reactivity increases down the group because the atoms themselves get larger. Therefore, the outer shell electron is further away than the nucleus, from the nucleus. Therefore, the attraction between the nucleus and the outer electron is weaker. Therefore, the electron is more easily lost. So, explaining this further, looking at this example of lithium and potassium, it's very obvious that the outer electron in lithium is a lot further away than a lot closer to the nucleus than the one in potassium, because you have one shell here in between the outer electron and the nucleus. However, on potassium there are 3 shells between separating the nucleus and the outer shell. Therefore, visually it's very obvious the difference. So the trends in reactivity of group 7 elements on terms of their readiness to gain an electron. So the group 7 elements are called the halogens, and the trend is that the reactivity decreases as you go down the group. But why? So in terms of group 7, they all have 7 outer electrons on their outer shell. Therefore, in order to have a noble gas configuration, they need to gain an electron to become stable. The trend in reactivity decreases down the group because the atoms get larger. Therefore, the outer shell is further away from the nucleus. There is less attraction between the electron and the nucleus. Therefore, it is harder to gain an electron. Again, looking at an example for fluorine and iodine, visually, fluorine is a lot smaller and there's only one shell between the outer shell and the nucleus. However, iodine is a much larger molecule and there are 4 shells between the outer shell and the nucleus, emphasising that gap. And the forces of attraction is a lot weaker in iodine, making it harder to gain that electron. So, in summary, the reactivity increases down group 1 as the outer electron is further away from the nucleus, therefore resulting in the forces of attraction being weaker. In group 7, reactivity decreases down the group as the outer shell is further away from the nucleus, therefore the forces of attraction is weaker. So, an exam question. This shows the boxes show some of the elements in group 1 and group 7. Explain, in terms of electronic structure, why potassium and chlorine would react the most violently. So, starting with potassium. Potassium is in group 1, and from the trend we've just learnt is that reactivity increases down the group because the outer electron is lost the most easiest. So, putting this into the exam question, the outer electron is the furthest away from the nucleus, therefore the forces of attraction would be the weakest. So the electron is lost a lot easier, hence reacting more violently. And it's really important that you use the phrases they've used in the question. So they've wrote that it reacts the most violently, therefore you should definitely include that in your answer. So the examiners can look straight to your answer, be like, yes, they've mentioned the more violently, and they can see that you've understood the question. So, moving on to chlorine. Out of the 3 halogens shown, chlorine has the least electronic shielding, therefore has the strongest forces of attraction. So this is basically, it has the shortest gap between the outer shell and the nucleus. This means chlorine will gain an electron more readily than the other 2, making it react more violently. Again, using the words in the question in your answer, making it obvious that you understand. And I've actually highlighted some key phrases in bold that you should definitely use in this kind of question, because it's just easy marks. Like that's what the mark scheme shows. That's what the examiner's looking for. So rather than making it more obscure, you want to make it clear. The examiner's marking a lot of papers. They want to just make tick 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 kind of thing. So the next question is showing 3 different halogens reacting with hydrogen and how they differ. So the question is, using your knowledge of electronic structure, explain why all the halogens react in a similar way and why they react more slowly on going down the group. So this question, basically has 2 parts. Why they react in a similar way and why they react more slowly. So you want to start with the similar way because it's the first one they've wrote down the question. So you would say all the halogens react in a similar way because they all have 7 outer electrons and wish to gain an electron to complete their shell. It's, as we learnt before, they all have 7 outer electrons. It's just a quick sentence. This is probably the one marker in the question, and the trends will be the 2 marker. So you just want to make it very clear that you understand and move on. And so the second part is why they react more slowly. And so the halogens react more slowly going down the group as the outer shell becomes further away from the nucleus, reducing the forces of attraction. Therefore, it is harder to gain an electron. So there's 2 things you must note here. You have to note that it's further away from the nucleus, therefore it's harder to gain an electron. If you don't mention one of them, you only get 1 mark. So it's really important that you list what's happening, so it becomes further away, and what is the consequence of that. Therefore, it's harder to gain an electron. So it's really important that you use both of those aspects in your questions. So that is the end of my presentation on the Group 1 and Group 7 trends. I hope you learnt something and I hope you enjoyed. Cheers.